Welcome to the UNC OBGYN Quality Improvement Lecture Series. This series of short lectures will introduce you to 7 of the most commonly used QI tools. These tools will form a basic toolbox so that you can complete a quality improvement project of your own. Let's quickly review the schedule for this class as well as for the class QI projects each class will do again this year. By the end of September, you should view the first 2 videos in this series. By the end of October, your class should choose a project and you should complete an aim statement and a process map for that project. You should also view the next 3 videos in the series by the end of October. By the end of November, your class should complete its fishbone diagram and driver diagram for your project, as well as view the last 2 videos in the series. By the end of December, your class should plan its first PDSA cycle and design its check sheet for data collection. And if these terms don't make sense right now, that's okay. They will as we go along throughout the course. By the end of March, your class should have completed data collection and analysis for your project, as well as any PDSA cycles past the first one that you want to complete. Then by mid-April, you will need to submit your poster, and at Resident Research Day 2016, you'll present that poster. Let's talk about our goals for this first lecture. By the end of this first lecture, I want you to start thinking about patient care as a process, and I'll explain what I mean by that momentarily. I also want you to be able to state the 3 questions which comprise the IHI model for improvement. And finally, I want you to be able to compose a good aim statement based on the 3 necessary components which we will discuss. Let's start with the idea of thinking about patient care as a process. What is a process? It's simply a series of actions or steps that are taken either in series or in parallel to achieve a particular end. The reason this can be really helpful when thinking about patient care is that often the different parts of a patient's care seem like these nebulous and sometimes unrelated pieces. But when you break things down into individual processes that have a beginning, a middle, and an end, and discrete steps, it makes it much easier to find concrete things that you can fix. A really good analogy to use in thinking about patient care is a conveyor. A conveyor moves objects from point A to point B. It consists of many individual sections that are joined together to form a cohesive unit, and together that cohesive unit moves the object from the beginning to the end of the conveyor. We can use that same analogy for a patient's hospital stay. Just like a conveyor should move something from point A to point B, a hospital stay should move a patient from admission when they're sick to discharge when they are well, at least well enough to go home. You can also use the same conveyor analogy for care in a continuity clinic. Long-term outpatient care should also, theoretically anyway, move a patient from initial evaluation when they present for a problem to resolution when that problem is resolved or controlled. You're probably thinking, and rightly so, that this is a dramatic oversimplification of patient care. What really happens during a hospital stay or during a series of outpatient visits is a complex web of many different processes that interact in many different ways. And that's true. But this analogy still holds. In a real warehouse, if a conveyor system breaks, you find the individual component that's not working and fix it. And that's what we're going to do in our quality improvement work, is find a particular process in patient care that's not working correctly and fix it. Let's think about a couple of real-world examples. Labor and delivery is a complex web of many different processes occurring all at once. We could look at one particular process in that web, the triage evaluation of pregnant patients, from presentation through the decision to admit or discharge. That's a very discrete individual process. Why would we want to look at that? Well, if that particular process fails, it can result in preventable maternal or fetal complications. There's a whole list of them that I'm sure you can think of. Unrecognized preeclampsia progressing to eclampsia, decreased fetal movement that precedes IUFD, labor that's unrecognized that results in a patient being discharged and delivery in the field. Many, many different things you can think of that would result from that process of triage evaluation breaking down and not occurring correctly. Another real-world example. This one takes place in the medical ICU or the MICU. It's the particular process of mechanical ventilation of patients in respiratory failure. In other words, the decision to intubate through the decision to extubate, that discrete process, which is one of thousands of different interconnected processes that happens in the MICU. You could focus on that because if that process breaks down, it can result in, among many things, ventilator-associated pneumonias, which everyone remembers lead to increased morbidity and mortality, increased length of stay, increased cost of care, lots of complications. We're going to keep coming back to this example during this course because I was tangentially involved with some quality improvement work in medical school that, one, provided some really great examples of a lot of the tools that we're going to be learning in this class, and two, is a real-world example of how a focused quality improvement project can have tangible and very beneficial results for patients by focusing on a discrete part of one process among many. These examples hint at why it's so important for everyone to get at least basic training in QI. So many of the complications we see in medicine are preventable and are due to faulty processes that have simply never been studied and never been fixed. You can think of quality improvement as just a set of tools to help you study a process, figure out what's broken, and fix it. I'm sure you probably know how to use a hammer and a screwdriver. So there are lots of things around the house that you don't need to call a handyman to fix. Think of this course as the hammer and the screwdriver, the basic tools to help you get started figuring out what's broken and fixing it. There may come a day when you don't have the right tool for the job, but at least if you have the basic tools, you can do most of the work yourself. So now with that background in mind, today we're going to talk about the Institute for Healthcare Improvement's model for improvement and our first tool, aim statements. The IHI model for improvement is simply a framework for thinking about improvement in any system. We're going to keep coming back to this model for improvement throughout the course because all 7 of the tools that we will learn fit into the model for improvement by answering one of the 3 critical questions that you have to ask before starting a project, or by contributing to the Plan, Do, Study, Act cycle, which is where improvement occurs. So the 3 questions that you ask before beginning the first cycle improvement are: what are we trying to accomplish? How will we know that a change is an improvement? And what changes can we make that will result in an improvement? Once you've answered those questions, and particularly used some of the tools we're going to learn to answer those questions, then you plan and execute consecutive Plan, Do, Study, Act cycles to make the improvement you want to make. So now we can talk about the first tool in our course, the aim statement. An aim statement is simply a tool to help you answer the first question in the model for improvement. What are we trying to accomplish? It seems easy, right? So how about this? Let's take an example that's non-medical that I'm sure most people have experience with. What if our project is trying to lose weight? Let's come up with a sample aim statement for that project. How about this? I'm going to try to lose weight. Okay, so what's wrong with that aim statement? As anybody who has ever tried to lose weight knows, that kind of aim statement is so non-specific that it's really not going to motivate you to do anything. And even if it motivates you to lose some weight, how do you ever know if you've really accomplished your goal of losing weight or losing enough weight? The key to a good aim statement is that it should define success with regards to your project in measurable terms and with a deadline. It should clearly state 3 things: how good, by when, and for whom. When you make an aim statement that specifies those things, you give yourself concrete goals that you can then set to accomplishing. So let's try that again for our project of losing weight. So how about this? I will lose 10 pounds by June 1st. If you look at those 3 elements we talked about, this aim statement contains all 3. How good, by when, and for whom. This is the kind of concrete aim statement that will allow you to measurably achieve your goals by the deadline you've set. Now you try it. Which one of these is the best aim statement for a project? I'll give you about 15 seconds. You can pause the video if you need longer. the only one of these aim statements that contains all three of those elements we talked about is B. I will finish a marathon by 6/1/2016. How good, by when, and for whom. The other three answers are missing one or more of those concrete parts of an aim statement. But all of the examples we've talked about so far have been in very simple systems. So now we're going to do a little bit of role playing and think about how to come up with an aim statement in a more complex system. We're going to go back to the MICU. Imagine you've been there for a couple of weeks, and as you'll recall from the MICU, many of the patients are intubated. Let's say you've noticed that of those intubated patients, 4 have developed ventilator-associated pneumonias, and one of those patients died. So you decide to start a project to reduce the number of VAPs in the MICU. I want you to think for a minute and try to come up with a good aim statement for this project. Here are 4 possible aim statements for this project. I want you to take about 20 seconds to read through them and figure out which one addresses all 3 of those components of a good aim statement. The best aim statement for this project is D, because it addresses how good, by when, and for whom. All 3 of the other statements leave out at least one of these components. That's it for aim statements. They're really a very simple tool, but as long as you answer those 3 critical questions with your aim statement, they're a very powerful tool for setting your project up for success. As you probably gathered from the last few slides, in order to create a well-informed aim statement, you need some baseline data. You have to know where you're starting in order to know how much, by when, and for whom you're going to improve. But if you're thinking about those 3 components of a good aim statement as you're formulating your project, that will help you, 1, figure out what background data you need, and 2, it will make sure that you are planning outcome and process measures that are measurable. And that's very important as you move forward through the rest of your project, so that you make sure that at the end of your project you have something that you can measure to indicate that improvement has been made. What now? Well, now you need to get together with your class and brainstorm about what problem or process to address with your class project. If you're having trouble coming up with ideas, you can think about preventable complications or near misses that you've seen or that have been presented at M&M. You can also think about the Institute of Medicine's dimensions of healthcare. Well, what are those? The Institute of Medicine came up with 6 aspects of good patient care, with the acronym STEEP. They say that good patient care should be safe, timely, effective, efficient, equitable, and patient-centered. So you can think about some aspect of patient care that you've seen that was not one of those things, and try to figure out how to make it so. That's it for the first lecture. Thank you for your attention, and I'll see you again next time.